All right, we all set? Great. Good morning, everybody. Thank you for joining me. We're going to talk about building SaaS microservices this morning. And I'm going to try and show you some ideas and some tricks and some patterns to help simplify the development process to make your product teams more efficient, building the things that your customers are asking you for. My name is Michael Beardsley. I am a solutions architect, and I work on a team at AWS called the SaaS Factory. And the goal of the SaaS Factory is really to make AWS the best place to build your SaaS solutions. And we do that by interacting with our partners and our customers, giving best practice and guidance. And we also build a lot of reusable content, both written content, but also a lot of code samples that you can find out there on GitHub that you can take advantage of to help sort of accelerate your journey. Just as a reminder, this is a 400-level session. I'm going to be showing a lot of source code on the screen. I hope everybody's excited about that. And with that, let's dive in. Okay, so let's set the stage here. Let's make sure we're all talking about the same thing. So up on the screen, I've got a very generic microservices architecture. And there's a couple of things that we can notice about this. One is that there is going to be some sort of user interface client that you have. Usually these are written in a JavaScript framework like React or Angular, but this might be a mobile application or some other way to interact with your microservices. This user application, this client, talks to an API gateway. And the API gateway sits in front of all of your microservices and presents a cohesive look at your solution that's made up of all these different services. And that API gateway talks to some sort of identity provider. Here I've shown Amazon Cognito, but it could be any identity provider. The point is that we want to make sure that our requests against our microservices are authenticated. We know who's asking to use them, and they're authorized, that they can actually do what they're asking to do. And then that proxies down to your microservices. And you'll notice that all of my microservices are independent of the other. And this gives us the ability to scale these microservices independently. It gives us the ability to deploy these microservices independently. And it gives us flexibility to use the right tools for the job. So you'll notice that each of these microservices might be using a different type of compute. Maybe we're using containers in one. Maybe we're using EC2 instances in another. Maybe we're using Lambda functions and putting all of that behind an API gateway. You'll also notice that each microservice owns its own database, owns its own data source. This is super important for microservices to maintain their independence and flexibility. And it also gives us the ability for each microservice to use the right kind of data technology for whatever that service does, whether it's a NoSQL solution, a purpose-built database, or a traditional relational database. So this is the kind of architecture that we want in our heads as we go through the rest of the talk. So as we start thinking about moving to delivering our products through a SaaS delivery model, or if you're already there, what are some of the things that might be different that you need to think about versus a more traditional delivery model? Well, one is tiering. So we often like to package up our SaaS offerings in a way that delivers an experience that our different customer segments are interested in. So the classic example here might be like a standard tier versus a premium tier. Or maybe you've got a free trial or a paid trial tier. And these tiers are going to impact how you're writing your microservices. And they're certainly going to impact how you're provisioning your infrastructure and utilizing resources. Data is key to succeeding as a SaaS vendor. You have to know what your customers are doing with your services, and maybe more importantly, you need to know what they're not doing with your services so that you can gain insights into what's going on so that you can increase their loyalty and retain their subscription and grow your business. So gathering up these actions, this audit information, and these metrics that tell you what's going on with your running system are key in a SaaS solution, and you have to have tenant context when you gather up this information. And that's what's different about this than a traditional model. Now, most customers expect a SaaS solution to be billed with some concept of consumption-based pricing, right? Customers want to pay for what they use. They don't really want to pay for anything more than that. So now we have to think about gathering up the data that identifies what each tenant is consuming so that we can invoice them properly. We call that metering. We're going to spend a lot of time this morning talking about identity. We have to know who's interacting with our microservices, and more importantly, what tenant they are interacting with us under, so that we can build isolation into our solutions. We have to isolate each tenant's data and their actions from every other tenant in our system. So these are some of the ideas that we want to keep in mind as we're building SaaS solutions. So how does this impact our microservices architecture that we were just looking at? Well, on the front end, we need to be thinking about things like, how are we authenticating these users that are coming in to access our system? This is often where we're also gathering up the information that's going to be important for routing these requests to the proper back-end resources. So the metadata, whether it's a subdomain or it's part of the headers or some other piece of metadata, usually this is defined on the front door as it's coming through that front end. And because in SaaS, we want to be running a single version of the same code base for everybody, but if we want them to have a little bit different experience, you'll find that this is also where we're implementing feature flags to turn some things off, to turn some things on. As we go into the API gateway level, now we're talking about authorization. Are they authorized to do what they're asking to do? This is also often a place where you're looking at throttling, especially if you've tiered your service. Caching also happens at the API gateway level. And as we get into the microservices, now we're really getting into the meat of this data gathering with tenant context for metrics, logging, and of course, consumption-based billing metering. As our microservices talk to our data layer, now in a multi-tenant world, we have to think about how are we accessing those data resources? How have we partitioned our data resources so that each tenant's data, so that we know where it is and how to access it? How are we isolating that data from one another? Because partitioning is not the same as isolation. And we're going to talk about that more a little bit later. And of course, backup and restore with data gets really difficult, especially if you've pooled your data sources. And of course, all this is running on infrastructure, right? How we provision that infrastructure, what techniques are we using to implement isolation on that infrastructure? How are we maintaining it? And how is it changing and evolving and having to be modified as we bring on new tenants and as those tenants go through their natural life cycle of interacting with us as customers? So there's a lot going on here, right? And who has to worry about all this? The product development teams, right? The software engineers that are out there. And we want to make our developers productive. And this is nothing new. Software engineering has been trying to figure out how to make developers productive since the very first programs were written. And one of the main ways that we do that is through encapsulation. And encapsulation really just means gathering up both data and logic into some unit that can be reused, whether that's a shared library or whether that's more of even just a pattern of writing software like object-oriented code. And encapsulation hides away the complexity of what's really going on underneath, and it gives us a way to be more flexible as we build our systems. And it promotes reuse. And every time we can reuse something, we're going to save costs. We're going to save costs, both hard costs, but we're also going to reduce defects. Because now we just have one copy of this thing going out there, we can test it, and we can reuse it. It also starts to develop common patterns of how we want our systems to be built. This increases the efficiency of your team who's building this stuff, and it makes it easier for you to bring new people onto your project and get them up to speed more quickly. Let's take a look at a common example. I bet everybody here who's ever written a line of code has written some sort of logging statement before, right? So here's this super simple logging statement. It's just going to print this sentence out to its output. But think about all the complexity that's happening underneath that this logging module is helping us do. Right? This logging library, it's got to figure out how it's configured. Should it even be logging at the info level? If it is, it's got to figure out what the current thread is. It's got to go get the stack trace. It's got to get a bunch of metadata for the line number and the file name. It's got to wire up together all this metadata like timestamps. And then it's got to format the output. And then it's got to manage the actual I/O, which probably means it's got to buffer, it's got to flush, it's got to synchronize, and it's got to clean itself up to get ready for the next logging statement. So there's a lot going on here, right? Imagine if, as a developer, you had to do all of this every time you wanted to write a logging statement. What would happen? Well, you get a lot less logs. Our CloudWatch bill would go down, right? But what else would happen, right? Mistakes would happen. People would forget a step, or they'd get a step out of order, or they wouldn't implement something with best practices. And so the advantage here of encapsulating all of this complexity into a logging module, it makes us more efficient. It makes our software better. So this is the kind of concept that we want to keep in mind as we start talking about some of these things that we need to think about when we're building SaaS microservices. So let's start with a non-SaaS microservice. Let's make a really simple one here. We're going to define a function in our microservice to get a list of orders. If you don't recognize the syntax that's up on the screen, this happens to be Python. I chose Python not because I'm promoting the use of Python, although it's a wonderful language. I chose it because even if you have never seen a line of Python before in your life, it's pretty easy to understand. And it's also a pretty terse language, and PowerPoint is not the best IDE, so bear with me. So what is this microservice doing? What is this function doing? Well, not a whole lot. It's opening up a connection to Amazon DynamoDB. It's scanning a table and trying to find all the order items in that table for that user and returning a list of order objects to the client. Nothing about SaaS, nothing about multi-tenancy going on in here. Nothing about tenancy at all. So what's our first step then? How do we make this multi-tenant? Well, we should probably add a tenant, right? Seems pretty basic. So here we go. Here's our same function. Not a whole lot's different, but we've added tenant ID. And by adding tenant ID, we can now ask the real question, which isn't just give me all the orders for this user, it's give me all the orders for this user in the context of the tenant that they belong to. This also has allowed us to now communicate with DynamoDB differently. We can now do a query instead of a scan. A query is going to be more efficient, it's going to cost you less, it's going to be faster, and it's going to allow us to use some more advanced security features that we're going to talk about a little bit later. So this is great. We've got our tenant ID in here. We can now use it. How do we get a tenant ID? Where does it come from? Well, I suggest that the tenant ID should come through the request. So let's take a look at what sort of a natural request flow might look like. So our users, they ask our application for a list of orders, and the very first thing that our software does is it says, well, I need to know you are who you say you are. So we ask them to log in. And we interact with some sort of identity provider here. And usually this nowadays is implemented with OpenID Connect, which is a process built on top of OAuth, but you could be using SAML assertions or something else. The point is that your identity provider, after authenticating that user, is going to return a set of tokens. And using those tokens then, we're going to redirect our call back into our service, and we're going to say, no, we want a list of orders, and our API gateway then is going to verify that that security token is valid. It's going to make sure it isn't expired, It's going to make sure it hasn't been messed with between the time that it was issued and right now, and a bunch of other checks. And assuming that that all holds true and the call is authorized, then, of course, we talk to our microservice, which does its work and returns to our customer. So this is our standard flow, and somewhere in here, we're going to add the tenant ID. What are these security tokens that I'm talking about? Well, I'm talking about JSON web tokens, or JOT tokens, as some people call them, or JWTs. So what is a JOT token? Well, it's really nothing more than a base64 encoded string that's split up into 3 parts. The first part is the header, gives us the type and the hashing algorithm that was used. And then the middle part is the payload. And the payload is a list of key value pairs that tell us about the token, tells us about who issued it, some of the details about when is it going to expire, when should you start being able to use it, who's the intended audience, stuff like that. There's a whole list of standard claims. We call these key value pairs claims. But importantly, you can add your own key value pairs to these tokens. And that is how we are going to pass along the tenant ID. We call these custom claims. Last part of the JOT token is the signature. The signature is a combination of the header and the payload and a secret, and we can use that to ask the identity provider to verify that no one has modified the packet between when it was created and when we're using it. Okay, so now we know about these tokens. We know we're going to use them to get our tenant ID. So let's take a look at how we might do that in code. So here we are back at our function. And now up on line 2, you can see I am pulling the authorization header out of the incoming HTTP request. I'm extracting that bearer token. I'm splitting it up into its parts. I'm grabbing out the payload. And I'm getting the tenant ID as a custom claim out of that payload. Now you might ask, why do it this way? Why override the JOT token from the identity provider with custom information? Well, if I didn't get the tenant ID as part of the incoming request, I have to get it from somewhere, right? Which would mean that when my request hits and I don't have that tenant context, I'd have to go ask some probably other microservice that I wrote, like a tenant context microservice, let's say. Well, guess what? You're going to have to do that every single time you need the tenant ID. And by the end of this morning, you'll understand that you need the tenant ID for everything. And now you've created a microservice that is a single point of failure, and it's a hot spot in your architecture. And it should not be what you are worrying about. You should be worrying about writing whatever your intellectual property and features and functionality are that your customers want. So we can take advantage of the fact that this step has already happened, and it's happened before we've hit our microservice, and it's secure. So that's why we promote this pattern. So there's a lot going on in here, right? There's string manipulation, there's regular expressions. Who here has ever had a bug in a regular expression, right? So this is ripe. This is ripe for some sort of reuse. We should encapsulate this. There might even be more going on here. This assumes that the API gateway has already verified the token and we're not talking to the identity provider. You'd think decoding base64 would be easy. Sometimes you got to pad it out depending on how it was written. There's all kinds of stuff going on here. So this is the perfect example of where we should create some sort of helper for that process that can be reused between all of our microservices. So let's create a token helper that we can get a tenant ID out of any request. What next? What else should we do? Did anyone notice that there was no error handling in our microservice? Let's add some error handling. And if there's an error, we should probably log it. We should probably do something about the fact that there was an error. So here you see I'm building up my logging message. And I'm building up a structured logging message. I'm not just logging a plain string, which means I've got this pattern here that I need to follow. I need to add tenant context to it. And I don't want my developers having to remember how to build this every single time. That's too hard, that's too much. And in fact, it's probably more complicated than this, right? I'm probably trying to use an even more complicated structure than this. So again, ripe for encapsulation. So let's add a logging helper. Okay, so now we've got a token helper that can help us with a request. We've got a logging helper. What else is on our list? How about our discussion about consumption-based pricing? Let's say that we wanted to bill some of this service based upon the consumption of the resources that we have to pay for. Well, we can ask DynamoDB for a little bit more information about the query that we just ran, and we can bring back some information about the capacity that we consumed from that table, the number of records. Again, a somewhat complicated package of data that we want to build up here. We want to build it the same way. And then we've got to deliver it to our back end. Now here, this is showing an example using Kinesis Data Firehose, but you could imagine all kinds of different ways to ingest data into AWS. We have a rich set of services and features to pull that off. The point is, this should also be encapsulated and easy to use because you want to be gathering this data as a SaaS vendor. So make it easy for your developers to gather up a whole lot of data. We get asked so often, well, what should I be like? What metrics should I have? I don't know. You probably don't know either, so just start gathering stuff and put it in a structured format so that you can query it and learn and find signals and find patterns in your data, and then you can turn off the stuff that you don't need, and you can add more stuff that you do need. How about accessing our data? Well, not only do we have the tenant ID in our security token, we can also grab the tier, because when you onboard a new tenant, a tenant's actually onboarding into a tier. And so we know this information when we onboard the tenant, so we can add it to the identity provider, and now we can capture the tier. And using that tier, we can make some decisions. Let's imagine that we've got 3 tiers to our system here. Let's say we've got a trial tier and a standard tier, and maybe people pay us a little bit more money, they get some different features, and we've got a premium tier. And for the premium tier tenants, let's say they each get their own DynamoDB table. Different isolation, different noisy neighbor problems, different partitioning. And so now we can use this tier to impact how we access our data. So now when we give the DynamoDB client the table name, it's a variable at runtime. It's not static. And again, this whole idea here should be encapsulated into some sort of data access layer in your microservice, right? You should simply ask the data access layer, hey, here's this request. Go figure out how to get the data for me. Earlier I said partitioning does not equal isolation. What did I mean by that? Well, let's take a look at our example here, right? So we've got a couple of different tables. We've got our trials table, we've got our standard table, maybe we've got a few premium tenants. So we've partitioned the data here. We've either partitioned it physically in the example of the premium tier, where they have literally 2 different DynamoDB tables, or we've partitioned it logically by adding some sort of discriminator to the data. In this case, we would add the unique tenant identifier as the partition key in these pooled tables, and we would use that to filter out and know which items go with which tenant. So we've split them up, we've partitioned them. But we've done nothing about preventing somebody from talking to any of it. Why is that? Well, it's because when you create an AWS SDK client, by default, it uses the permissions and privileges from what we call the default credentials provider chain. What the heck is that? Well, that's the EC2 instance role. If you're running containers, that's the task role. If you're running Lambda, that's the execution role. So it's whatever IAM permissions you've given to the compute that's running your microservice. And so that SDK client is going to have access to all of these tables. So they're not really isolated. They're partitioned. but there's nothing preventing me from accessing something that I shouldn't be accessing in the context of an incoming request. So how can we fix this problem? Well, it turns out that you don't have to create the SDK client with the default credentials. You can create the SDK client with credentials that you provided at runtime. And therefore, we can change the security posture of this SDK client. This is true for any of the SDK clients, not just DynamoDB, before we start using it. So how do we do that? Here we are back at our flow. We've gotten to our microservice. We have an authenticated, authorized request. We're ready to go. We're ready for the microservice to start doing its work. But first, our microservice is going to go get a set of scoped down permissions that align with the tenant context of the incoming request. And then we're going to use those permissions to create a temporary set of AWS credentials. And these temporary credentials are going to time out. They're going to be short-lived. So even if something horrible goes wrong, you've got a small blast radius because they go away quickly. And we're going to use those credentials to access our AWS resource in the context of the tenant who's accessing our microservice, and then we're going to return the response. So how do we do that flow? How do we get those runtime credentials? Well, there's sort of two main ways to approach this, and they both have their pros and cons. So one way would be to create an IAM role and a set of permissions for each of your tenants. And really, you'd probably have to do this for each of your microservices for each of your tenants, right? Potentially for each tier. But you set this up, and then you use a feature of Amazon Cognito called Identity Pools. Not to be confused with, but always is, user pools. Identity pools are completely different. It's a completely different service, and what Identity Pools do is it allows you to exchange a Cognito identity for a set of AWS credentials. Perfect. That's what we need. And so what are the benefits of this model? Well, the benefits are that it's really easy to understand. All of the security posture of all of your tenants is right in your face. You can go look it up at any time. It's sitting in IAM. And you're using a managed service to do some of the wiring to get you the right one at runtime. That's nice. What are some of the downsides? Well, like pretty much every AWS service, there are account limits in IAM. You can only have so many roles and so many policies. And so if you have a lot of tenants and you've got a lot of microservices, this might not work for you. Plus, if you want to change any of those policies, right now you're thinking about a batch process across a whole lot of IAM roles. That gets kind of shaky too. So this doesn't scale super well, but it is easy to understand and it's convenient. So what if you can't work with those limitations? What are our other options? Well, our other option is to do some of the work ourselves. So here, we can use what we call an identity policy, which is the green circle on the left. The identity policy contains all the permissions that our microservice might need. And then at runtime, we can create what we call a session policy. And we can lay that session policy on top of the identity policy. And the intersection of those two, which is the little yellow shape in the middle, represents the set of permissions that we want to be able to use at runtime. And we get to this by calling one of the assume role methods from the security token service API. STS is part of the IAM service. Okay? Let's take a look at what these policies look like here. So here would be the identity policy. So this would be the policy for your microservice. So here we're saying we're going to allow read and write and update and delete all the CRUD methods on DynamoDB for the different tables that our order service has to worry about. So this is our identity policy, and now we're going to lay on top of this identity policy our session policy. And what our session policy is going to do is it is going to restrict, it's going to take away some of what's up here in our identity policy. So our session policy, same format, still a IAM policy JSON document. And so now we can start limiting what we want out of that identity policy. So instead of all the actions, let's say now we just want to read only. So now we're just going to allow query here. Now note that you can't add actions in your session policy that don't already exist in the identity policy. So for example, I couldn't add, say, S3 get object here because my identity policy doesn't have any permissions to talk to S3. So at runtime, I can't increase my permissions. I can just reduce them, okay? And now here I can restrict which tables. If I know that in this case this should be a read-only action against a tenant that's in my standard tier, I should only be talking to the tenant table. And remember earlier when I said when we switched from a table scan to a query, it opened up some other options for us. And those other options IAM calls request conditions. And so I can add a request condition on top of this policy that says for leading keys in DynamoDB, which means the partition key, the value of the partition key for that item has to equal this unique tenant identifier for me to be able to do a query against this resource. So we've now basically implemented row-level security inside of DynamoDB, and we can do it at runtime. So what does this look like in code? Well, we've got our two flavors, right? We've got our identity pools flavor, and then we've got our do-it-ourselves flavor. So identity pools are not maybe the easiest to understand, but the idea is that you get this common Cognito identity object, and then you give that identity object to the identity pools, and the identity pools will return you what it calls the authenticated role for that identity. And it can do role mapping by looking at the claims in the JOT token to figure out which IAM role should be the authenticated role for this identity. So these tenant credentials that you see here, these are the scope down credentials. In this case, they're the ones that you pre-populated when you onboarded that tenant for this microservice. Now, every SDK does this a little bit differently, but all the SDKs have the ability to do this, which is to override the default credential provider chain at runtime. So in Python, we create what's called a Bodo3 session with these runtime credentials instead of whatever the default credentials are that it's running on your compute. And then using that session, we ask for the SDK client that we want. And so now this DDB client that I've got here at the bottom of the screen, all of its actions are going to be restricted to whatever permissions are available inside of the set of credentials that I just gave it. What does it look like if we're going to build our own? Well, I don't have a policy, so I got to build one at runtime. So I should make some sort of template out of my policy. So here I've got a template object, and you see it's got 4 variables in it. And at runtime, I can fill out those 4 variables. Remember, I got which table to talk to from looking through my tiers, and I got my tenant ID. And maybe I need a couple of other little pieces of information to build up the ARN for the resource that I want to talk to. And now, I'm not using identity pools, right? So I'm not using Cognito anymore. Now I have to interact with STS myself. So I ask STS to assume this identity role, and because I'm now calling assume role myself, I can pass in my scope down policy. Now when you call get credentials for identity on identity pools, it's doing assume role for you behind the scenes, right? So it's saving a little bit of latency because it's making that call to the STS service on your behalf up on AWS before the return from Cognito comes back. But this gives us more flexibility. And then just as before, same thing, you now have a set of scope down credentials, you create a session with that, and you create your SDK client with it. Now you may be thinking, this is great, yeah, I get it, it's complicated, there's a ton of steps, I'm going to encapsulate this, and I'm going to have some sort of shared library that vends out my SDK client. My developers are going to say, hey, some sort of factory builder pattern or something, give me a DynamoDB client, here's the request that I want this client for, and that's great. What if my developers forget or don't know, and they just call bodo3.client? What's going to happen? They're going to circumvent all this fancy security that I just spent all this time trying to build. Well, one of the neat things about this pattern here is that because we're no longer using the default credentials, we don't have to give those default credentials any permissions to talk to DynamoDB. So even if your developer creates a DynamoDB client outside of the scope of your patterns here, they're not going to be able to do anything because those credentials aren't going to have access to any DynamoDB actions. So we've talked a lot about code, and I want to leave you with some thoughts about DevOps. So in a traditional model, DevOps is really about provisioning the infrastructure and deploying your workloads to get your software up and running, right? And that's essentially a one-time deal. It's one time every time you update your software. Some companies have super fancy CI/CD pipelines, and they're constantly setting up the infrastructure and deploying their code. But you're only doing it when your code changes. In a multi-tenant world, in a SaaS world, you have to think about what impacts does onboarding a new tenant make to your DevOps world. When you onboard a new tenant, are you going to have to provision some infrastructure to support that tenant? You're probably going to have to create some of these security policies that we've just been talking about, whichever flavor you want. You're going to have to set up those custom claims in your identity provider. You might have to deploy some workloads. It depends on how your architecture is set up. You're probably going to have to wire up a billing integration or some other third-party integration that your solution depends on. And it's not just when you onboard a new tenant. You also have to be thinking about what happens as the tenant continues to exist as a customer for you and goes through some of its natural life cycling. What if a tenant moves tiers? Right? What if they're in your trial experience and they love it and they're like, I am ready to commit, I'm ready to go. Are you going to bring along that experience that they've had, or are you going to make them start over again? What if you're moving data from a pooled resource into a siloed resource, or vice versa? How are you going to deal with that? What does it mean to your infrastructure to disable a tenant? It might mean changing a load balancer rule to have a fixed redirect to say, you haven't paid your bill, please call customer support. It may mean moving them to a different tier. It may mean throttling them. It could mean all kinds of things, and it's going to be different for everybody's solution. What does it mean if a tenant decides to leave? What if they unsubscribe? What if they ask to be forgotten? Right? So these are the kinds of challenges that we have to think about in a SaaS world with DevOps. Now we've talked about some of the things that we should be encapsulating and some of the things we should be figuring out how to reuse. But depending on whether we're using EC2 instances or containers or Lambda functions, the way that we can share those constructs might be a little bit different. And so I want to kind of cover that here. And I've chunked these up into sort of three categories. The first category I will call shared libraries. And this is the basic, this is the traditional thing that all of us know about, right? This is the traditional packaging, whether it's a Java archive in the Java world or a DLL in the .NET world or node modules, what have you, right? So these are shared libraries in your technology space. They're packaged with your microservice. They're versioned. And importantly, they run in the same process as your microservice. So they're running in the same memory space, in the same process, in the same virtual machine as your microservice. And because they're running in the same process, it means that you pretty much have to use the same language. Right? So whatever you wrote your microservice in is probably what you've written your helper in. This works great on EC2 and in containers. When you build your container, you have to remember to build your shared libraries and include them when you build your image so that it's all there at runtime. But this is pretty straightforward. We've been doing this for years and years and years. Now, with Lambda functions, this gets a little bit more complicated because a Lambda function is packaged up individually as each function. So your microservice is probably made up of a whole bunch of Lambda functions. Right? It's one microservice. It's the orders microservice, but maybe there's like 10 functions that make up the orders microservice. Each of those 10 functions need to be able to access your shared library. So now you've got to build that shared library, bundle it into your Lambda function, and deploy it. But that now means you've got 10 copies of your shared library floating around out there. And one of the values of using Lambda functions for your microservices is you don't have to change all 10 of them all at the same time. Again, it just makes our agility more and more and more fine-grained. So if a microservice can be independent and you can deploy and scale and deal with each microservice independently, now with serverless microservices, you can do it at a function level. So you could find yourself in a place where you've got drift in the versions of your shared libraries if you're not careful. And boy, wouldn't that be a hard bug to figure out what the heck is going on. Why one little piece of your orders microservice is doing something than all the rest of it. So how do we solve that problem in Lambda? We came out with Lambda layers. So Lambda layers is a mechanism for you to do shared libraries in Lambda. Lambda layers are independently versioned, provisioned, and deployed, and you attach them to your function. So now you have one copy of your shared library that you can attach to all the functions inside of your microservice. The next bucket I'll call background processes generically here. So the classic example of this would be a background process running as an agent or a daemon on the operating system. Now, these shared constructs do not run in the same process as your microservice, right? So these are now independent of your microservice, and your microservice is going to communicate with these background processes either through the network stack or through whatever the operating system uses for inter-process communication, whether that's pipes or sockets or what have you. So a good example of this might be something like the CloudWatch logs agent that is running on all your EC2 instances if you built them from an Amazon AMI. And its job is to sit there and watch for log files and log output and gather it all up and buffer it all up and figure out how to submit it out to CloudWatch, right? So this works great on EC2. You're in control of the operating system. You're in control of all the processes that your microservice is running next to. It doesn't work so hot on containers because, by definition, containers only run one process. That's why we have to give our image definitions the command that we want it to execute when it runs. If anybody's ever tried to run a cron job inside of a container that's also trying to run something else, you know what I'm talking about. The whole point of Docker was to only run one process at a time. So how do I run a background process in a container? Well, we can use the sidecar pattern, right? And the sidecar pattern is really just another container next to the container that is your microservice, but because they're running together inside of Docker, Container D, or whatever is running your containers, now these two containers can interoperate with each other, again, usually over the localhost loopback address. Right? So you would expose your different helpers, maybe on different TCP ports, and because you're not actually going out on the network, it's very low latency, high performance, and it's maybe a good example here might be like the FluentBit sidecar, right? Again, having to do with logging, you send all your log messages to FluentBit or FluentD, and then it deals with gathering stuff up. I should mention that Lambda functions aren't a long-running process, so there is no concept of background processes in Lambda because there's no background. So the last category here, I'll call interceptors. So the first flavor of interceptor would be network proxies. So what I mean by interceptor is something that is intercepting the flow, the natural flow of your microservice code before it is invoked and after, so before the request comes in and after the response is going out to your client. So a good example here might be like the Envoy proxy, which is what enables service meshes in like Istio in the containers world, or maybe a Squid reverse proxy for people who have been doing this a little bit longer than containers. Right? Same idea. It's intercepting the incoming traffic. It can affect that incoming request, and it can affect the outgoing request. The downside of this is it doesn't really have as rich of context about what the request is because it's not running alongside your microservice, and it only has the information that's available on the incoming network request. So how do you get beyond that? Well, you can run the same concept of intercepting the request coming in and the response going out, but you can do it right next to your microservices code with some sort of what I'll generically call middleware. Now, all the major frameworks have some concept of middleware, whether it's Node Express or Go Chi or the Spring Framework or message handlers in .NET. Everybody's got some concept of the request is coming into my microservice. I've got all the context of that request. I can interact with it and do stuff with it. I can run the main functionality of my microservice, and then I get a handle on that response before it goes out the door. Again, these two concepts work great on EC2 and in containers, but they don't work real well with Lambda because you're not in charge of the life cycle of Lambda. Your Lambda function gets lit up and torn down by the Lambda service. So you don't have a way to hook into what happens before it gets lit up or after it gets torn down. But you know that there must have been some way to do it. How does X-ray work if there's no way to understand what's happening before the Lambda function lights up and after it comes down? So clearly, AWS had a way to do it, and so we've now exposed that functionality in a set of APIs that we call Lambda extensions. So there are now APIs to give you hooks into the life cycle of your Lambda function, where you're told your function's about to light up, and you're told your function is done, and I'm about to return back to the client. So this is a really powerful way now to implement middleware techniques in Lambda functions. Lambda extensions are bundled up and packaged and delivered just like Lambda layers are. So they count against the number of Lambda layers that you can have for a function, and they impact, of course, the code size of your Lambda functions. But there's a lot of neat ideas that you could now imagine as you're thinking about the logging and the metrics and some of this other stuff that you can now implement using middleware. So what are our takeaways? Multi-tenancy is really going to impact all the different parts of your microservices architecture, so we have to be thinking about it. We want to simplify the fact that we have to think about it by using encapsulation to hide away some of the details and provide these reusable constructs to our product development teams. If you don't take anything else away from today, please think about using runtime security policies as you access AWS resources. It's a very powerful solution that we have for multi-tenant workloads on AWS. Depending on what you're running your microservice on, you might have some different options available to you in terms of how to reuse these encapsulations. And think about how you could squirrel away some of these things in middleware so that your microservices code doesn't even need to know that it's happening. We have a ton of SaaS sessions this year at reInvent, more breakouts like this one, workshops, chalk talks, which are a little bit more of an intimate experience where you get to interact more with the presenter. And the SaaS Factory has a ton of content and functionality available to help you accelerate on your SaaS journey. So I encourage you to check some of that out. So thank you. That's what I have for today. Hopefully everybody learned something.